it's one-to-one, but I want us to be able to do everything algebraically. So in calculus, you'll see that the stuff we do is so simple and intuitive, unlike this class. But the algebra is very, very difficult. So it's easy to understand, but hard to show. Okay? So here we go. How do we prove something is one-to-one? Let f of A equal f of B and show A equals B. So it's pretty simple. Just put everywhere there's an x, plug in an A. Set it equal to everywhere there's an x, plug in a B. And do you remember our first step here? Anybody remember the first step? Cross multiply. What's next? What's next? Distribute, or FOIL if you must, right? 5b minus 15 minus ab plus 3a on the left. 5a minus 15 minus ab plus 3b on the right.
So we should cross multiply. We multiply a.
Bottoms up, so the denominators go up. Yes, up, yeah, up and diagonal, yes. What goes away here? Yes, AB, yes, and? Yes. So we're going to move all our A terms to one side and all our B terms to the other. So the A's move left by subtracting 5A, and the B's move right by subtracting 5B. Don't let me run you over, you're paying me. So I subtracted 5A from both sides, right? And then I subtracted 5b from both sides. So what's on the left now? Minus 2a equals minus 2b, and now I'm dividing both sides by negative 2. So I get a equals b. That's what I wanted. Right? Since f of A equals f of B, go ahead.
Why did the two ABs cancel out if they're both negative?
The two ABs, where are the two ABs?
A took 5, B took 15, took 8.
Okay, nice. So 15 and 15 cancel. AB and AB cancel. Because remember, I'm going to add AB to both sides. Yes. So we knew f was 1-to-1 by looking at the graph, but sometimes you can't tell, right? Because there is a possibility for a function to cross a horizontal asymptote in the short run, meaning close to the origin. So Graphically, it's not as clear as algebraically. Algebraically, it's definitely clear. How we doing? Yeah, so 3a minus 5a is minus 2a, right? 3b minus 5b is minus 2b, then I divided by negative 2 on both sides. Ben, question? Because I need the denominator to be 0 and the numerator not to be 0. So what makes downstairs 0 is 3. If I plug 3 in upstairs, I get 2. So vertical asymptote. Right? All this stuff has to go on your formula sheet, right? Because it's a lot to remember. It's too much to remember. Yes, I can show you that again today. All right, let's find the inverse. So we're going to find g of x equal to f inverse of x. Anybody remember how to start? Let f of x equal to what? Y. So y is 5 minus x over x minus 3, right? Solve for what? Solve for x. How should we start? Cross multiply, right, by x minus 3. So on the right side they cancel. On the left side, I just get that product.
So when you cross multiply,
Yeah, I took that x minus 3 and moved and bottoms up. Yeah.
Okay.
Now what? What's next? What's that? Yeah, I have to distribute to get the x released. It's kind of in jail right now in that parenthesis. Yep. xy minus 3y equals 5 minus x. Now I want to isolate. I want all my x terms on one side with the speculation of try to minimize the number of negative signs.
So you want to distribute that x to the side.
So I want to move that x.
So plus
Yeah, and then I want to move the 3y. Notice when I move a term from one side to the next, it changes signs. Factor. Right? Now it's like I have 5 times some number, right? So that means I can divide by that number and solve for x.
oh.
Then what?
By y.
Nope.
Y plus 1.
Nope. Just replace. Replace x and y. Remember, inverse functions, the x's and y's switch places.
Okay, so I'm
Yep.
x is 5 plus 3y. So did you just divide again?
Exactly. So this is like some number like 7. So 7x equals 5 plus 3y. Divide by 7.
Oh, so once you get to that point, you just reverse that.
Exactly. So g of x, which is f inverse of x, is 5 plus 3x over x plus 1. Let's remind ourselves what f of x was. It was 5 minus x over x plus 3. What was the domain of f? Do you remember? Nice. And the range of f, the horizontal asymptote? Y not equal to what? What height don't I hit? Right there on the screen. -1. So y does not equal -1. What's the domain of g? Yep. What's the domain of my inverse function g? X does not equal -1. Guess what? Not a coincidence. And my range of g? Y does not equal what? +3. Right? Look at the mother function upstairs, 3x. Mother function downstairs is x. 3x over x is 3. It's not a coincidence. Notice what happened. The domain and range switched. Because domain is x, range is y. When you're coming up with an inverse, x and y switch. Rafi? 3 is fine, because 3 plus 3 is 6 downstairs. Oh, I have the wrong function. It's x minus 3, right? Sorry. Thank you. That's better. Thank you.
So the answer would be f of x is not equal.
What is your question though?
I know
For g of x? For g of x, I'm asking what's the range? Everything but y is 3. And that turns out to be the same as the domain of the original. Everything but x is 3. So it's not a coincidence there. It's happening on purpose. Hey, John. It's not a coincidence.
That's the inverse.
Yes. Kayvon's here? Nice. So a question just like that on your next quiz. What should I be able to do with these two functions? I should be able to do 2 or 3 things with these functions to verify. I can graph it, right. So I want to graph both of them. And when I graph both of them, what should I see? They might touch. I'm not sure about that, but something else. Yes. More. What are you seeing? When I have inverses, what are they to each other graphically? Identical. No reflection. But about what? Yeah, about what? Over y. About y equals x. Why? The inverse does what? What's the inverse supposed to do? Takes the x and makes it a y. Switch the x to y. Right? So, for example, on my first function, on my original function, if I plug in 1, what do I get? 5 minus 1 over 1 minus 3, 4 over negative 2, I get negative 2. So on my original function, guys, on my original function, right, I have the point 1, negative 2. On my original function, which is in red, I have 1 comma negative 2. Which means on my inverse function, in purple, I had better have what point? Negative 2, 1. That's it. That's a key. What's the next thing I should check? Well, I kind of just did. So yes, but I agree with you. Either I can look at the graphs and see the symmetry, or I could plug in a 1, get a negative 2, plug in the negative 2 to the inverse, get back to a 1. They better get me back to where I started. But I want to do a composition. So f composed of g should equal x, and g composed of f should equal x. Let's do f composed of g. So what's my outside function? Yeah, what's the outside function? What's on the outside? F, exactly. So 5 minus x over x minus 3 with empty parenthesis. Right? I'm writing the function f with empty parenthesis. Agreed? And what am I going to put inside? G, which is 5 plus 3x over x plus 1.
What are you doing here?
We're composing the two functions together, and they should fall apart because they undo each other. Everything should disappear except for x. Everything should disappear except for my original input. So what's the process now? Nope. We're going to clear fractions with x plus 1 over itself. Yep, so don't think. Memorize first. Write it down. The process is not going to change. If I have fractions within fractions, clear the fractions. So I'm distributing to my numerators. So in black is the original. In green is my that piece that I'm distributing in. So I guess the first question is, where the hell did the x plus 1 come from? The denominator? Yeah, the interior denominator, right? But I'm only allowed to multiply by 1, so I multiply by that thing I want by over itself. I'm distributing into every numerator, into the 5, into the function g, into the function g, into the 3, right? Everybody with me? You see that? What cancels on purpose? The x plus 1's here cancel. The x plus 1's here cancel. I'm trying to take my time when I do this. I'm not in a rush.
Sorry to ask, why did it cancel when they're both positive?
One's in the numerator, one's in the denominator, right? So look what I got. 5 times x plus 1 minus 5 plus 3x, right? These canceled, right?
Okay.
Yep, over 5 plus 3x minus 3 times x plus 1. Notice I didn't distribute at the same time. I'm trying to take my time because I know I can make mistakes if I do too many things at once. Right? When I'm eating a hamburger and changing the radio and driving. So I get 5x plus 5 minus 5 minus 3x. I'm just distributing over 5 plus 3x minus 3. And some things are going away. The 5s are going away here. The 3x's are going away here. So I have 2x over 2, which is x. And that's what I wanted. Right? I want those two compositions to give me x. Ivan, you okay?
This is finding the
Yep, finding and checking the inverse. So let's recap for the quiz next class, right? I'll give you a second if you need to still copy. Okay. Yes. Where are you there? Good. So we're going to factor a polynomial, right, using synthetic. We're going to graph a rational function. We're going to prove a function is one-to-one. And we're going to find and prove an inverse. Yeah, 4 or 5 there, yeah. Okay? Nice. Let's move on, because we got lots to do. Rafi, what? Yes. Right there, yeah? Yeah, is that okay? Nice. Leandro's not here. Francisco's not here. Sina's not here. Chris is supposed to be here. Not yet. All right, here we go. New stuff. We're working on 5.3. So we just did 5.1 and 5.2 over, right? The rational function was 4.4, 4.5. So here we go, 5.3. We're talking about exponential functions. So y equals a times b to the x is an exponential function. Now, better yet, let me just say b to the x is an exponential function, where b is a real number, b is greater than 0, and b is not equal to 1. B to the x is an exponential function, right? B is the base, right? X is the exponent. So I guess the first thing of interest is why can't B be 1 or 0 or negative, right? I'm saying B is greater than 0, so it can't be 0, it can't be negative, right? So B does not equal 1 since y equals 1 to the x equals 1 for all values of x, right? Does that make sense? So it's boring. B stands for boring. Boring is all hell in this case. B cannot be 0 since y equals 0 to the x for x bigger than 1 or x bigger than 0 is always 0. Again, boring. But worse, y equals 0 to the minus 1 is what? What's that negative 1 mean in an exponent? Is it a what? Nope. It's a reciprocal. So it's 1 divided by 0, right? Which is undefined. B cannot be negative for example.
What does that say about works?
Huh? But worse. And y equals negative 1 to the 1/2 is what? What's a half power mean? Very good, square root. So I have a square root of a negative 1, right? Which is imaginary.
So half power is essentially square root?
Yep. We only want to deal with real numbers. This class does deal with complex numbers, but when we're talking about an exponential function, it should always be real valued. Kind of boring. This is kind of boring, but I can't do anything about it. I have to teach it to you because you have to be able to solve these kinds of equations. I haven't gotten there yet, but very soon I'll get there, solving exponential equations. Let's play around a little bit on Desmos and write, I guess, f of x is equal to a times b to the x minus c. Oops, sorry. It won't let me do it. Oh, I know why. Parenthesis. X minus c plus d. And you see I'm going back to my shifts and transformations, right? I'm going back to my transformation. So what I'd like to make is A is 1 so that there's no stretch, right? I want to make A as 1 so there's no stretch. What's that? It's an exponential with all of those possible shifts, right? But I'm really thinking of b to the x as my mother function. I want to let c be 0, and I want to let d be 0. So there it is. There's my exponential function. So what are some things you could state about this? Domain? Everything. How wide is it, right? Range? Not everything. 0 to infinity, but not 0, right? Horizontal asymptote? Yes. Right? So, what happens if we start moving things around a little bit, right? What if we let A be negative? Right? So now I'm right reflecting everything. All the positive y's become negative y's, right? Yes, you with me? Oops, sorry. I lost my function. Oh yeah, I want A to be 1. Watch what happens when I move C to the right, right? It's X minus something, so it's moving to the right. I should have put it as plus C, but right, remember we said X's move inversely? And then if I move the D, the whole thing moves up, right? Or down. Simple, yes? So, I mean, the worst thing that the book could do is ask you to graph one, but you're going to use Desmos and then think about it, right? So let's take a look at the book here. This is section 5(3).
So what we wrote down earlier about that was that the law of exponential.
It's just how do you make an exponential function? What's got to be true about the base, right? So so the first thing they do is start graphing, and they'll graph with a table. So they're graphing 2 to the x and 6 to the x. I might as well do that real quick. So I'm on Desmos. I'm going to graph y equals 2 to the x and y equals 3 to the x. And I'm just going to pick a bunch of points. So I'm clicking in the box with the function. Make sure you watch me do this. I'm clicking in the box with the function. I go to the gear and I pick a table, and then it's going to generate a bunch of points for me, right? So in 3 to the x, hit the gear, hit the table. What's happening to the exponential when the base is bigger? And positive, right? The black is 2 to the x, the red is 3 to the x. It's getting higher faster when the base is bigger and positive, right?
It slows down as it goes to negative.
Yep. So if I look at another one, so when you get one of these, you're just going to put it in the calculator, right? So but what if I had y equals 1/2 to the x? Look at what's happening. Why did it reflect that? So black is 2 to the x. Red, the other red, the new red is minus 1/2 to the x. Sorry, 1/2 to the x. So I'll say it again, like this on paper. Y equals 2 to the x gave me this function. Y equals 1/2 to the x gave me this function. What's another way of saying 1/2 to the x? It's 2 to what power? No, what power?
Oh, no. Oh, no.
Negative x. And so you remember that negative on the input will switch to reflect about y. Right? What does negative power mean? Reciprocal. The reciprocal of 2 is 1/2. So the book's going to give you a bunch of functions to graph. It's going to ask you domain. It's going to ask you range. It's going to ask you horizontal asymptote, right? They should all be kind of obvious. They should all be kind of obvious. What's the domain here for my blue function? It's all numbers, right? Look how wide that blue function is. What's the range? 0 to infinity, right? It doesn't hit 0, it doesn't hit negatives. What's the horizontal asymptote? Yep, y equals 0. Y equals 0, right? It never gets to the height of 0. So what's this going to do? It's going to take my 3 to the x and move it up where? Right? What's the domain? All real. What's the range? Nice, 1 to infinity. And what's the horizontal asymptote? Y equals 1, right? It took that whole thing and moved it up 1. Right? CD, all I'm asking is what height is it getting to, really close to, but never getting there? Yep.
That would be the horizontal axis.
Yes. So graphing, do it on Desmos. I'm never going to ask you to graph one. The book will. Yes. So here's one. F of x equals negative e to the x minus 3. So e is a number, right? Do we know e? E is approximately 2.7 something. Because I'm a math teacher.
So E's actually a number?
Yeah. 2.718281828. There's no, it never ends and never repeats. This is like, it's irrational. E is irrational. named after Leonard Euler. Euler is his real name. I like saying Euler, but
Are we supposed to know that E is 2.71?
no, it's on your calculator, just like pi is. It turns out, I mean, E is kind of interesting. Let's see, the amount of money in your bank account is the principal times 1 plus, don't tell me, R over N to the NT. Yes. So A is an amount. P is the principal, right? Initial amount. What you put in the bank or what you charge on your credit card. R is the interest rate. T is time in years. I'm not sure my formula is right. Let me fix it in a second. But N is the number of times compounded per year. Let me just check my formula real quick, okay? It's just something you learn in finance class. Yeah, I got it right. So when you probably learned how to calculate simple interest when you were in 8th grade or 7th grade. Yeah, question. T is the time in years. So what I want to do is I want to invest $1 for 1 year. And I want 100% interest. Right. So if I compounded once a year, right, at the end of the year, I'd have another $1, 100% back. 100% of $1 is $1. Right? So every year I'd get another $1. But what I want to do is I don't want to compound it once a year. I want to compound it 1,000 times a year. How about 1 billion times a year? How about every nanosecond? So I want to compound it an infinite number of times. Right? Let N go to infinity. I'm going to compound it in infinite. Meaning I'm going to calculate how much you owe me if it's a credit card every second of the day. It's going to keep going up and up and up. Right? And so if we take a look at this, the amount I'm going to have is just going to turn into 1 plus 1 over N to the N. I'm gonna use X, okay? I'm going to Desmos. You can go with me. I'm going to use a table, right? Say again? So I'm gonna put it in for, I'm gonna compound it once. I got the $2, right? Do you see it? When I put in 1, I got $2. 1 year, compounded once, I got $2. Let me compound it 10 times. $2.59. So if I compound it 10 times in a year, well, maybe 12 makes more sense every month. $2.61, right? How about every week? What is there? 600, 300? How many days a year? 365? 2.7. Let's just go nuts and do it like 100,000 times a year. You can see E, 2.72. E is the maximum amount you can earn. This is why pi is as important to circles as E is to finance. E is this magical number inside of finance. Anyway, I got distracted there. Let's go back to the problem. I had f of x negative e to the x minus 3. So they're going to ask me a bunch of questions. Of course, I want to look at the graph on Desmos, okay? So y equals, f of x equals negative e raised to the x minus 3. What's making it move down instead of up? That leading negative, right? Remember that's saying that's an outside negative. So it's taking the y values and taking the positive ones and turning them to negative, right? Does that make sense? Outside is y's, inside is x's, right? Where did it move the original function to? So look at y equals e to the x. That's the original function, right? Yes? And then if I move that by minus 3, where does it move it? Which way? 3 to the right. Good. So you could, oops. E raised to the x minus 3. So I'm moving everything by 3 to the right. Right? Do you see the red move to the right by 3? And then that negative on the outside reflected it down, right? So anyway, this is stupid stuff. I kind of want to just read this section and then tell me what you don't understand, but it's okay. I want to get to one last thing here, and that is solving an exponential equation with matching bases. This is our last thing to do in this section, and we can take a little break. Solving exponential equations with matching bases. So the first example we have here is 4 to the 2x minus 1 equals 8x. So by the way, these exponential functions are what kind of functions? What kind of functions are exponential functions? How many kinds of functions do we have? Is there any repeated heights? No. So they're one-to-one, right? So if I know that 2 to the a equals 2 to the b, what else do I know? Exactly. So we're trying to get this one to say base, right? What base, by the way, do you see here for the 4? And what base do you see for the 8? 2. Good, I got 2 squared raised to the 2x minus 1 is equal to 2 cubed raised to the x. Why did I what?
Why did you write it differently? I'm sending you the same thing, but is there a reason why you did it like that?
Well, 2, meaning colors?
No, I'm talking about like 2 to the third.
Well, 2 to the third, 2 times 2 times 2 is 8.
Yeah.
Yeah. 2 times 2 is 4.
Yeah.
But I want the same base.
Oh.
Right, right. So what do I do when I raise a base? When I raise an exponent to an exponent, what do I do with the exponents? I multiply them. So on the left, I get 2 to the 2x minus 1, 2 times 2x minus 1. And on the right, I get 2 to the 3x. And now, because I know they're 1 to 1, what can I say? I can say that 2 times 2x minus 1 has to equal 3x. Because the bases are the same and the function is 1 to 1, if the bases are the same and the exponents have to be the same, if they're equal. So what do I get? I get 4x minus 2 equals 3x. So I get x equals 2. That's simple. So you're going to try and rewrite your base to be the same base, right? Rewrite the bases to have the same base, and then set your exponents equal to each other and solve.
Is reason x is equal to 2 because the base is 2? Or?
Nope. Nope. I subtracted 3x from both sides. I got 1x minus 2 equals 0. I added 2 to both sides. I don't show this stuff anymore. This stuff. I just expect you to be able to move something and change the sign, right? And you can kind of see that if I move the 3x to the left, it becomes negative, and the 2 to the right becomes positive. Right? Do you see that? 2 to the. Yep. Good. Let's do another. Yep. Yeah, get the bases to be equal. Yep. Soon, 1 second, just waiting. Yeah, good, thanks. So let me jump right to problems. I like definitely up to 87. I like up to 87. So this is a 5.3, right? Suggested problems. I gave you enough homework for Monday, right? Okay. But the ones that I could possibly see myself asking you would be 55 to 87. So let's do a couple of those and then take a quick break. This is number 75. It says 3 to the x squared minus 7 equals 27 to the 2x. Well, can you recognize the base right away that I want? 3, right? So 3 to the x squared minus 7 should be equal to 3 raised to what power? Yep, 3 to the third raised to the 2x. when I'm raising an exponent to an exponent, I multiply the exponents. So I get 3x squared to the x squared minus 7 equals 3 to the 6x. Since my exponential functions are 1 to 1, right, I know x squared minus 7 better be equal to 6x. And this is a quadratic, right? So I get x squared minus 6x minus 7 equals 0. And this one factors. Anybody see it right away? Yep. X minus 7, right? Great. So what are my results? X equals 7 or x equals negative 1. And this is the thing. I can have extraneous solutions. I can have solutions that the algebra gives me, but they don't work in the original. So I have to check both of them. I have to check both of them. And it's kind of weird in that you would think, well, if I have matching heights, I better have matching x's. If I have matching y's, I better have matching x's. But the difference in this one is that I've got this quadratic in my exponent, right? So we're going to check these by hand. You can certainly check them on Desmos. Let's check x equals negative 1. Question? Yeah, 3 times 3 times 3 is 27. Yep. Yep, that's okay. So I get 3 raised to the negative 1 squared minus 7 should equal 27 to the negative 2. So I'm plugging in that negative 1, right? That makes sense? So it looks like the negative 1 works. Right? I just have to get something the same on both sides. I could go to here to check, but I'm worried, what if I made a mistake when I simplified, right? You know what I'm saying? So I'll check x is 7. Yep. So I want to check both until I see that I don't have extraneous. Say again? Yep. Yeah, and I checked them both in the original.
And all you did was, so you just put it in wherever x was?
Yep. All right, let's take a 4-minute break, okay? I'll leave this up here. Let's come back at 3:30, finish up.
Oh my God, what a headache. Why a headache?
Yeah. Yes.
So are these problems, the problems are gonna be on the test as well, or
Those are the ones I want to turn in. These are suggested.
which ones can I review for the like I can try for
All of those.
all of those? So nice.
They're going to get you every type of problem I want you to be able to do.
The quiz is coming out on Wednesday.
Mhm. If you did the ones I did in class, that's enough. I can't give you anything more difficult.
No, I just want to practice for myself. Just to
Yeah, yeah.
make sure I understand.
For the one-to-one functions, pretty much any linear over any linear that aren't the same will get it to you. So x minus 5 over 2 minus x, or 2x plus 1 over x minus 3, anything, those are all one-to-one.
Yeah, I understand the one-on-one part. I do understand.
Yeah, but then finding the inverse,
That's what I'm.
so do the same, show the one-to-one, find the inverse, do the composition. Then the other one is factor, and then right? And the rationals.
So what's going to be the test? I'm going to do
Factor of poly
the
with synthetic, right? Graph a rational function. Prove an inverse, find an inverse, check an inverse. Yep. Yeah, yep. It's here. I wrote it, right? Factor a poly using synthetic, graph a rational function, prove a function's one-to-one, find and prove the inverse. Pepsi Zero. I can't have. No, I can't have sugar. Diabetic. Hmm? Diabetes.
Huh?
What?
Do people with diabetes eat rice?
No, rice is not good for you. Yeah. I know. I love rice. Chinese food. Yep. A lot of sugar in the sauces too.
Yeah, I don't really with the sauces. I'm not a big fan of those.
Boy, if you're not diabetic, you don't care. Eat rice.
No, I have diabetes in my family, so I'll be watching that.
Yeah, yeah.
And that's the main staple food. So what you be having instead of rice?
Quinoa, all this like hippie crap.
I don't know what that is.
It's a grain. It's an ancient grain. Yeah.
Try some quinoa and see what it tastes like. Just because you said it. You look disappointed.
Yeah. I mean, I can have anything in moderation, but that's my issue.
I know how that is. I know, you talking to someone who understands. Once you like it, you like
You
it.
like it, right? All right, let's go. Let's do this next section. I'm going to have to push the test back a week, but that's fine. We can still do the quiz Wednesday. I'm just not going to get through the rest of 5. I need one more class. So let's do our next section here. This is 4.4. Sorry, 5.4. Log functions. So the first thing about log functions that we have to know is hey, you made it. I recorded everything, so yeah. So the first thing we want to know about log functions, and we have all these properties of log functions that we have to know, but it's very, very simple in that if y equals b to the x, our very first translation is log base b of y equals x. Make sure you say that with me so that you get the idea here. If y equals b to the x, we know b is the base, x is the exponent, right? Yes? And so look at what happens. I get log base b of y equals x. So this is a translation that's going on our formula sheet. And we should be able to take any function and convert it this way. So for example, if I have y equals 2 to the x minus 3, what's my translation here? Log base what? 2 of y is x minus 3. So our exponential equations for us, our exponential functions are pretty natural. Raising 2 to some power is easy for us. Log functions are not that easy, but if we can first translate it with this equivalency, then it should be easy. Eventually, so when we get something like this, we're going to convert it into this. And eventually we won't have to. We'll be able to think about it in terms of a log function. So let me put these two into Desmos so you can see what happens, right? So and I got to cheat this a little bit, so bear with me. I want to start with my first one, y equals 2 to the x. And I'm putting in y equals log base 2. Let me see if I can do this. I have to go down to this little toolbox down here and look at functions. Here it is. So y equals log base 2 of x. Now I didn't switch my x and y there, but you and I both know, right, that when I'm writing it like this, I want to keep y as the name of the function. But take a look at these two functions. Do you see anything that you notice? Say again? Yes. They're inverse of each other. So there's my, right? So these are inverse of each other. So just by using the same base from the exponential to the log, right, I get inverse functions. You see that? So what's interesting to me is what is the output of a log function? Well, look at the translation. What's the output? What part of the exponential function is it? No, yeah, this was just another example, right? So, but looking at this purple box here, I'm looking at x as the output of a log function, right? But what's another way to think about it? Look at the translation. What is the x? What part of the exponential function is the x? An exponent. So you're going to see we're going to learn a bunch of properties about logs, and they're going to follow the properties of exponents. For example, when you're multiplying like bases, what do you do with exponents? When you're multiplying like bases, what do you do with exponents? You add them. When you're dividing like bases, what do you do with exponents? Subtract them. So you'll see when we start talking about the properties of log functions, it's the same as the properties of exponents. So we're going to think this stuff is difficult because that's what we like to do as humans, make things difficult. But it's not, especially if your first thought is change it back to an exponent. Okay, change it back to the language you know, right? Anybody speak Spanish here? What does yo no sé mean? Yo no sé, anybody know what yo no sé means? It means I don't know. I was going to say, I thought you told me you could speak Spanish, but you ruined the joke. So, but in my head, when I'm saying yo no sé out loud, I'm saying I don't know. I means I don't know, right? Same thing here. When I'm speaking logs, in my head, I'm translating to exponentials, okay? So, for example, right, log base 3 of 27 equals x. I don't know if I could think of that right away, but I can translate it. What do I get when I translate it? 3 to the what? X is 27. So now it's easy, x is 3. So right now, your goal is going to be translate everything. If you get a log, translate it to exponentials, okay? The book's going to ask you, hey, translate this exponential to a log, translate the log to an exponential, and solve if possible, okay? If I say to you, log base 2 of 8 is x, do you know what exponent I need? Do you know what exponent I'm talking about? Do you know what base I'm talking about? 2. Down, do you know what exponent I'm talking about? 3. Right? So translation is 2 to the x is 8. What exponent makes 2 into 8? 2 cubed, right? 2 times 2 times 2. So you don't have to think in terms of logs yet. Okay? Not yet. Very soon. So, but right now you're converting into exponentials and then solving. I like problems in this section I'll get there eventually. Oh, I skipped 2 sections. Damn it. Here, I'll do it this way. Sorry. Up to 109, up to 111. So, yeah. So, I'm not done with this section, but really close because it's easy. So, suggested problems, 5.4, 1 to, what did I say, 107? 5.3, 1 to 87, 5.4, 1 to 107. Let's do a couple. They're easy, okay? But you'll get one every now and then that you're confused about, and there's nothing wrong with that. So here we go. This is number 89. And I have log base 3 of x equals to 2. Anybody know the answer right away? You know the base. You know the exponent. What's the missing piece? Sounds like I'm talking German. 9. Yeah. So translate. Base to the exponent is the argument. So x is 9. Simple, right? Yeah. Let's do 105. Log base 3 of x squared plus 1 equals 2. What's the base? What's the exponent? What's the argument? X squared plus 1, right? Yes? So x squared must equal what number? Almost. Almost. Other way. 8, right? 9 minus 1. So x equals plus or minus square root of 8, which is plus or minus square root of 4 times square root of 2. So x is plus or minus 2 rad 2. Hopefully you remember doing all of that stuff in Algebra 2. Algebra 1, Algebra 2, when you were solving quadratics, you had to do stuff like that. All right, one last thing in this section, and these are called the special bases. So if I say to you log base 10 of x equals y, that is equivalent to the log of x equals y. So because we're base 10 people, right? Do you understand? We're base 10 people. Our whole system of counting and adding and subtracting and multiplying all came from fingers in the Mideast, ancient times. And so base 10 is so special, we just call it the log function. So for example, log of 10 is what? Anybody know? Do it on your, if you have your calculator, or if you do it on Desmos, it's fine with me. Log of 10. So log of 10. Oops. Nope. 1. Right? So what's weird here is the base is what? What's the base in this problem? And it's all about the base. If you, it's a joke. It's all about the base. What's the base in this problem? 10. What's the exponent? Good. What's the answer? What's the argument? 10. So what number, 10 to what number is 10? 1. When you translate it, it's very easy, okay? So our first special base is base 10. So we don't say base 10, we say log. The next special base is base E, from, again, Leonard Euler. So if I say to you log base E of 1 equals 0, that should really just be read as ln of E. Sorry, ln of 1 is 0. So the natural log is log base E. ln is natural log. What is the natural log of 1? Well, I'm telling you 0. But what's our translation? What's our base? E. What's the exponent? And what's the argument? 1. And e to the 0 is 1, right? You agree? I'm just riffing. So 2 special bases and a translation. We need those for the rest of our mathematical careers, okay? So they have to go in the formula sheet. I will ask you to use them on the test. I'm expecting you to know, right? So like look at a problem here in our textbook. Look at number 103, right? And they're asking me to translate and possibly solve this, right? You with me? So this is 5.4, number 103. And I've got e to the 2x plus 5 equals 8. I don't know if I could solve this, but I'm going to find out. So how do I translate this to exponential? I've got ln, or log base e, but we'd rather write ln. What's the argument? 8. And what's the value? What's the exponent? 2x plus 5. So if I solve this for x, right, what do I get? I get 2x equals ln of 8 minus 5, all divided by 2. E is log base e is ln. So when I translate this thing to a log, yes. Now, why did I have to translate it? If I'm going to solve this one for x, why do I have to translate it? I have no choice. Why? I'm solving for what? X, right? But where is x in this original problem? Where does x live? In the exponent. How the hell do I solve for x if it's in the exponent? And this is something that's going to happen quite a bit. We're going to have these exponential functions, and in order to get that exponent down, we're going to have to use a log function or an exponential function. We're going to use an inverse function to get it down.
So the log function makes it so that it's equal to 2x plus 1.
Yes. So I can get a decimal, of course, right? So going to Desmos, what was it? ln of 8, right? Minus what? 5 all over 2, right? So I don't mind you getting me a decimal, which I'll call an approximate solution, but I always want the exact solution. So this is exact. Always want the exact solution, okay? And then I can do an approximate, what was it, negative 2.05. I want to do one more thing. I know you're at your edge, but let me do one more thing, and then I'll repeat it next week. But I just want to get it started Wednesday. I'll repeat it Wednesday, okay? So here we are, 5.5 properties of logs. And I'm going to include in these properties the first two that we already learned. The first one that we learned was the translation. First three we learned, right? So log base b of y equals x translates into b to the x equals y. That was our first thing. That I'm going to call that one my translation. The next one are my special bases. Log base 10 of x is the same as log of x. And the preference is on the right. We want to use the one on the right. Log base e of x is the ln of x. And we have about 10 more, I think, that when you're going to start to use them, you're going to feel very, very uncomfortable. You're not going to know what the hell's going on. And you got to fight through it. You got to do problems and fight through it. So the first one is, if I have the log of a product, I get the sum of the logs. Thanks. Nice. Chris, is this the stuff due Monday? That's fine. Last Monday or this Monday? Okay. Yeah, that's fine. What am I doing there? I'm multiplying like bases. What's the base here? What's the base here on the left? What's the base? 10. Right? Log is just base 10. Right? So I'm saying log base 10 of a times b. I get log of a plus log of b. What are these guys? Exponents. When I'm multiplying like bases, I add the exponents. Yes. Log is base 10. Right here. Log is base 10. I'll prove that one to you, okay? It's easy. Let's look at the two more first. Log of a divided by b is log of a subtract log of b. And log of a to the n is n times log of a. I'm going to prove the first one and the third one. You are going to have them on your formula sheet and you're going to memorize it. Okay? So let's prove the first one and then quit tonight, okay? I'll prove the first one and then we'll quit. Can you handle it? You don't have to write the proof down, okay? You're not responsible for the proof. I won't ask you to do the proof. If you're a math major and none of you are, I would expect you to know the proof, okay? So let's start with this. This really translates to what? Well, let's do this. Let's do it this way. Let me take this whole property, and on the right-hand side, let me rewrite. So let me call this thing, I better not use it. Let me call it x and y, okay? So I'm saying log base 10 of a is x. Somebody translate that for me. Yeah, 10 to the power of x is a. Good. I know log of b is y translates into 10 to the y equals b, right? So if I take this information and look at a times b, what do I get? I get 10 to the x times 10 to the y, which 10 is 10 to the x plus y, right? And now look at log of AB. That is now log of 10 to the x plus y. Let me call that something. Let me call it z. Translate that for me. What's the base? It's not written there, but it's understood. What's the base? 10. So 10 to the z equals 10 to the x plus y, which is saying that z equals, because it's 1 to 1, x plus y, there it is, z equals x plus y. Quick example, let's say log of 2 times 50 How does that, what is that? That's log of 100, right? 2 times 50 is 100, right? What do I get on the right with my property? I get log of 2 plus log of 50, right? Yes, you agree? 2 times 50, I'm separating the product into two sums, right? Into a sum? All right, let's see what happens. Log of 2 plus log of 50. It's 2. not so easy to see on the right-hand side, but easy on the left. What base is this? 10. What exponent makes it into 100? Start reading that section. It's very confusing. In fact, it's confusing for students even once they get into calculus, especially if they don't practice. So start reading up to 5.5. We'll finish chapter 5 Wednesday. We'll do the test the week after, not next week. Yes? Say again? Both. When you read the book, do the examples. Yeah, Ben. I am giving you a midterm grade. I'm testing 3 tests and a final. So your midterm's supposed to happen now. I'm not ready. If they fire me, you'll see someone else next week.
I heard you the best, they can't fire you.
But I'm going to just come up with a midterm grade and give that to you. Midterm grades have one purpose, either to allow your counselors to schedule you for Calc 1 or light a fire under your butt so you get to work. That's it. It goes to no one else. Yeah.
If I do this, problem, can I send it to you just to make sure?
Yes, of course, always.